It is the morning of June 6, 1816. A farmer in Vermont walks out to check his fields and stops. The corn he planted 3 weeks ago is buried under 6 inches of snow. His sheep, sheared just days before for summer, are freezing where they stand. The birds in his trees are falling out dead. It is June, and his world is a glacier. 5,000 miles east of him, on the same day, it is raining ice in Quebec. In Ireland, 8 straight weeks of rain are about to destroy every potato in the country. In China, the rice fields are dying. In a Geneva villa, an 18-year-old girl is locked indoors by a storm that won't stop, and she is about to dream up a monster called Frankenstein. The entire planet is losing its summer at the same time, and nobody, anywhere in the world, has any idea why. The answer was buried 8,000 miles away, in a mountain that, 14 months earlier, had stopped existing. This is the story of how one volcano on an island most people had never heard of froze the entire planet, how it killed, invented, inspired, and reshaped the modern world, and how it took human science almost 200 years to figure out what had happened. To understand what happened in 1816, you have to go back 1 year to April 1815 and to a mountain that, at the time, nobody outside of Indonesia had ever paid attention to. Mount Tambora, on Sumbawa Island in the Dutch East Indies, was 4,300 meters tall. That is 14,000 feet, higher than any peak east of the Mississippi River. It sits directly above the Sunda subduction zone, one of the most violent geological seams on Earth, where the Indo-Australian tectonic plate dives beneath Eurasia at a speed of 7 centimeters per year. For 5,000 years, Tambora had been silent. But beneath the surface, something dangerous was happening. Hot, water-rich magma was rising into a chamber 4 kilometers below the summit. It was cooling, it was crystallizing, and as it crystallized, it released gas. For centuries, that gas had been building pressure inside the chamber. By April 1815, the pressure inside Mount Tambora had reached nearly 5,000 bar. To put that in perspective, that is more than 5,000 times the air pressure you are breathing right now. A bomb that had been ticking for 1,000 years, and nobody knew it was there. On the evening of April 5th, 1815, the first explosions came. They were so loud that British troops stationed on Java, 800 miles away, marched out believing a neighboring fort was under attack. Coastal vessels set sail to rescue a ship in distress, but there was no ship. There was no battle. The sound was the mountain, and the mountain was just clearing its throat. 5 days later, on the evening of April 10th, Tambora reached its climax. The Raja of Sangar lived directly at the foot of the mountain. He survived. His eyewitness account, recorded by a British lieutenant sent to deliver emergency rice, is the only first-hand description of a VEI-7 eruption ever written down. About 7 p.m., 3 distinct columns of flame burst forth near the top of the mountain, and after ascending separately to a very great height, their tops united in the air. In a short time, the whole mountain appeared like a body of liquid fire extending itself in every direction. Raja of Sangar, April 1815, VEI-7. That is the second highest classification on the Volcanic Explosivity Index, the most recent confirmed VEI-7 eruption in human history. Here is what that actually means. It was 10 times more powerful than Krakatoa, 100 times more powerful than Mount St. Helens in 1980, 1,000 times more powerful than the Iceland eruption that grounded European air travel in 2010. In a single afternoon, Tambora ejected 41 cubic kilometers of magma. That is roughly 10 billion tons of raw, blown out of the side of a mountain in hours. The plume punched into the stratosphere at an altitude of 43 kilometers, 3 times the cruising altitude of a 747. And then, the summit collapsed. When the smoke cleared, Mount Tambora had lost 4,700 feet of its own height in a single day. Its peak had collapsed inward into a caldera, 6 kilometers across and 700 meters deep. The mountain had eaten itself. The kingdom of Tambora at its base. An entire civilization was gone, wiped out by pyroclastic flows moving at over 100 miles per hour at temperatures above 1,000 degrees Fahrenheit. A 4-meter tsunami struck the surrounding islands. The sound of the explosion was heard 1,600 miles away. Approximately 71,000 people died on Sumbawa and Lombok. It is the deadliest volcanic eruption ever recorded. But here is the part that should keep you awake at night. The eruption was not what killed most of those 71,000 people. And the eruption was not what was about to kill people on the other side of the world. Tambora's deadliest weapon was invisible. This is the part of the story that took scientists almost 200 years to figure out. Because what makes a volcano like Tambora truly catastrophic is not the lava. It is not the ash. It is not even the explosion. It is the gas. When Tambora erupted, it injected an estimated 60 megatons of sulfur dioxide directly into the stratosphere. That is 6 times more sulfur dioxide than Mount Pinatubo would later inject in 1991. But why does that matter? Because in the stratosphere, between 15 and 50 kilometers above the Earth's surface, there's almost no weather to wash anything away. So the sulfur dioxide just stayed there, and it began to react. Sulfur dioxide plus water vapor equals sulfuric acid. Tiny droplets of sulfuric acid, each one less than a micrometer wide, began to form across the entire upper atmosphere. These droplets are called sulfate aerosols, and they have one specific property. They scatter sunlight. When sunlight hits a sulfate aerosol, some of it bounces back into space before it ever reaches the ground. Now imagine that. Spread across the entire upper atmosphere of the Earth. A planet-wrapping veil, dimming the sun. Within months, the veil had drifted around the equator. It had seeped into both hemispheres. It had reached every continent. And by the spring of 1816, 1 full year after the eruption, the average temperature of the entire planet had dropped by approximately 0.5 degrees Celsius. That number sounds small, but every degree Celsius below normal shortens a growing season by about 2 to 3 weeks. And in 1816, that was enough to break the food supply of the entire northern hemisphere. The world had no idea what was coming. The summer of 1816 began with a cruel deception. In Salem, Massachusetts, on April 24th, the thermometer read 74 degrees Fahrenheit, t-shirt weather. Within 30 hours, it had crashed to 21 degrees. Then came June. On the night of June 6th, 6 inches of snow fell across New England, in Plymouth, Connecticut. A young clockmaker named Chauncey Jerome later wrote in his autobiography that he walked to work that morning, quote, wearing heavy woolen clothes, an overcoat, and mittens. In June, the drifts in Cabot, Vermont, reached 18 inches deep. Frozen birds dropped dead in the fields. Some Vermont farmers, who had already shorn their sheep that spring, tried to tie the fleeces back on with string. The animals froze to death anyway. In Cummington, Massachusetts, Sarah Snell Bryant, mother of the famous American poet William Cullen Bryant, wrote a single line in her diary. Quo card, weather backward. Sarah Snell Bryant, summer 1816 diary entry, Hutton Library, Harvard University. 2 words. 2 words that say everything about how the world felt. In Cape May, New Jersey, frost was reported 5 nights in a row in late June. On August 20th, a violent storm dropped temperatures 30 degrees in a few hours in Amherst, New Hampshire. And it snowed. In August, a killing frost on August 28th destroyed what was left of the corn crop. The Vermonters, desperate, starving, gave that summer a name they would never forget. They also called it the Poverty Year. In Ashland, New Hampshire, on a south-facing hillside, a farmer named Reuben Witten managed, somehow to grow 40 bushels of wheat. He shared every grain. He never sold a kernel. When he died in 1847, the people of Ashland paid for his headstone. The original misspellings, preserved on stone for almost 2 centuries. Quote card. A pioneer of this town, cold year of 1816 raised 40 bushels of wheat on this land which kept his family and neighbors from starvation. Reuben Whitten Gravestone at Monticello. The retired President Thomas Jefferson lost most of his crops and slipped deeper into debt that would eventually force the sale of his estate. In a letter to his former Treasury Secretary on September 8, 1816, he summed up the year in one sentence: "We have had the most extraordinary year of drought and cold ever known in the history of America." Thomas Jefferson, September 8, 1816. Vermont alone lost between 10 and 15,000 people to westward migration that year. 7 years of population growth erased. Among the families who fled was a struggling farmer named Joseph Smith Sr. After 3 crop failures in Norwich, Vermont, he moved his family to a small town in upstate New York called Palmyra. His 11-year-old son was named Joseph Smith Jr. He would later found the Mormon Church. The year without a summer didn't just kill harvests. It rewrote the map of America. Across the Atlantic, the disaster was worse. Summer 1816 in Europe was the coldest of any year between 1766 and 2000. In Ireland, it rained for 8 straight weeks. The potato crop failed, the wheat crop failed, the oat crop failed. A typhus epidemic followed. Between 1816 and 1819, an estimated 100,000 Irish people died. In Britain, food prices doubled. In England's eastern counties, unemployed laborers raised banners with 2 words on them. The Ely and Littleport food riots ended with 5 men hanged. A historian later called it the last great subsistence crisis in the Western world. In Germany, a 13-year-old boy named Justus Liebig watched his neighbors starve in the city of Darmstadt. The horror burned itself into him. 30 years later, his work on synthetic nitrogen fertilizer would change global agriculture forever. In Mannheim, Germany, Baron Karl von Drais watched horses starve as oat prices spiraled. He decided that humanity needed transport that didn't eat hay. In June 1817, on a road in Baden, he rode the world's first bicycle. The bicycle, in a real documented sense, is Tambora's child. But in Asia, the disaster was something else entirely. The Indian summer monsoon collapsed for 2 consecutive years. Drought was followed by unseasonal flooding in the Bay of Bengal, and there, in the warm, contaminated water, a bacterium that had been mostly local for centuries mutated. In 1817, a new and far deadlier strain of cholera erupted out of Bengal. It traveled with British ships to every continent on Earth. By the end of the 19th century, that pandemic had killed tens of millions. A volcano in Indonesia had killed people in cities they could not have placed on a map. In China's Yunnan province, 3 years of cold rain destroyed the rice crop. The poet Li Yu-yang, watching his neighbors starve, wrote a poem titled simply, "Bitter Famine." In it, a mother carries her child to a deep, clear river. She will care for that child in the life to come. There, Li Yu-yang, Bitter Famine, Yunnan, c. 1817. Of all the strange things Tambora's Bale produced that year, one of them is something you have almost certainly heard of. In May 1816, on the cold and stormy shores of Lake Geneva, an exiled Lord Byron rented a grand mansion called the Villa Diodati. His group was joined by an 18-year-old named Mary Wollstonecraft Godwin, her lover, Percy Bysshe Shelley, her stepsister Claremont, and Byron's young physician, John William Polidori. They had come to Switzerland for a summer holiday. The Bale had other plans. It proved a wet, ungenial summer, and incessant rain often confined us for days to the house. Mary Shelley, Introduction to Frankenstein, 1831, trapped indoors for days at a time, in candlelight at noon. They read German ghost stories aloud to each other. One night around mid-June, Byron proposed a contest. Each of them would write their own ghost story. Astronomers at Texas State University, who reconstructed the lunar geometry of that exact night, have pinpointed the moment Mary Shelley's, quote, waking dream came to her. It was between 2 and 3 in the morning, on June 16, 1816. She dreamed of, quote, the pale student of unhallowed arts kneeling beside the thing he had put together. That dream became Frankenstein. The first true science fiction novel ever written was born in the cold shadow of an Indonesian volcano. But it wasn't the only thing. Polidori, working from a fragment Byron abandoned, wrote The Vampira. It was published in 1819. It is the direct ancestor of every romantic vampire from Dracula to Twilight. and Byron himself, locked indoors that July, wrote an apocalyptic poem called Darkness. Its opening lines describe exactly what people across the northern hemisphere had been experiencing for months. I had a dream, which was not all a dream. The bright sun was extinguished and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Lord Byron, Darkness, July 1816, in London. The painter J.M.W. Turner watched the Tambora Vale for years. Modern atmospheric scientists at the Academy of Athens measured the red-to-green ratios of his sunset paintings and published their findings in the journal Atmospheric Chemistry and Physics in 2014. Their conclusion: the reds in Turner's sunsets correlate precisely with known volcanic aerosol levels in the atmosphere. Turner, in other words, without ever knowing why, painted Tambora, and here is the strangest part of the entire story. For over a century, nobody connected any of this. In 1816, nobody believed that snow in Vermont, famine in Ireland, cholera in Calcutta, and Frankenstein in Geneva all came from the same source. A scientific link to Tambora was first proposed in 1913 by an American climatologist named William Humphreys, but the scientific community largely ignored him. The mystery sat untouched for another 70 years. It was finally solved in 1984. A NASA scientist named Richard Stothers published a paper in the journal Science. It was titled simply The Great Tambora Eruption in 1815 and Its Aftermath. He had pulled together the eruption records, the temperature data, the famine records, the temperature data, the chemistry of acid rain across the northern hemisphere. He laid them on top of each other, and the picture was undeniable. The final proof came from the ice itself. When sulfate aerosols fall back to Earth, they fall as snow on the polar regions. That snow gets compressed into glacial ice. Each year of snowfall becomes a layer. You can drill into a Greenland ice sheet and read history like the rings of a tree. And in the layer corresponding to 1815, there is a massive sulfate spike, a chemical fingerprint, a signature in the ice. The case closed. A volcano in Indonesia had hijacked the climate of an entire planet, and it took human science 170 years to figure out how. Now, the question that should be making your stomach turn: could it happen again? Until very recently, scientists believed that magnitude 7 volcanic eruptions occurred roughly once every 1,200 years. That math felt comfortable. It is not. In August 2022, researchers Mike Cassidy of the University of Birmingham and Lara Mani of Cambridge's Center for the Study of Existential Risk published a paper in the journal Nature. Using new ice core data, they revised the math. There is a 1 in 6 chance of a magnitude 7 explosion in the next 100 years. That's a roll of the dice. Cassidy and Mani, Nature, August 2022, 1 in 6, the same odds as a single roll of a die within our lifetimes, or our children's lifetimes. Another Tambora is statistically expected. The candidates being monitored most closely include Italy's Campi Flegrei, the supervolcanic field directly beneath 3 million people in Naples, Indonesia's Rinjani, New Zealand's Taupo, Japan's Area Caldera. And here's the part that almost nobody talks about. Some scientists have now proposed deliberately injecting sulfate aerosols into the stratosphere to deliberately replicate Tambora's effect as a last resort response to climate change. It is called solar geoengineering. Tambora is the natural experiment they are studying. It is also a warning, because the same aerosols that cool the planet also collapse monsoons, kill rice crops, and starve people on the other side of the world. Tambora killed 71,000 people directly. But the famines, the cholera, the typhus, the migration, eventually killed millions. In 1816, there were 1 billion people on Earth. Today there are 8. A modern Tambora against modern global food systems would not be a year without a summer. It would be a generation-defining catastrophe. 210 years after the explosion, Mount Tambora is quiet. Lichens grow in the caldera. Wild orchids bloom on the rim. The mountain has been demoted from a 14,000-foot giant to a 9,000-foot stump. But the lesson it left us is not in stone. It is in ice cores in Greenland, in a misspelled gravestone in New Hampshire, in a Chinese poem about a mother and a river, in an English novel about a man-made monster, and in the faint red of a Turner sunset. One eruption, one bad week on one obscure island, rewrote a year on the entire planet. It killed millions. It invented the bicycle. It wrote Frankenstein. It shaped religions. CIP, slow zoom out to planetary view Earth from space. The next one is not a question of if, it is a question of when and whether. This time, we are watching. If you made it this far, thank you for being here. These stories take time to research, to write, to edit. And every single view, every comment helps keep them going. So if you want to see more documentaries like this, consider subscribing and leaving a like. It genuinely makes a difference. And to everyone already supporting, whether you've been here from the start or just joined recently, thank you. You are the reason these stories get told. Stay curious, and I'll see you in the next one.